Hello everyone, today I am going to discuss the fifth problem of AtCoder beginner contest 346, which is paint. So what is the problem? We are given a grid with H rows and W columns. Initially all cells are painted with color 0. Now we can perform the following operations. We will perform the following operations same number of time. Any operation is given by a tuple of three integers, which is Ti, Ai and Xi. So what does it mean? If Ti equals to 1, we will repaint all cells in the Ai row with color Xi, and if Ti equals to 2, repaint all cells in the Ai'th column with color Xi. After all the operations, we have to for each color I that exists in the grid, find the number of cells that are painted with color I. So let's take one example to understand it better. So for this example, we have a grid with 3 rows and 4 columns, and we have 4 operations. So in the first operation, what we are doing, we are painting the second row with color 5. In the second operation, we are painting the fourth column with color 0. In the third operation, we are painting the third row with color 3, and in the fourth operation, we are painting the third column with color 2. So let's look at the grid after each operation. So initially all the cells are white. Now in the first operation we are painting the second row with all fives. Okay, we are painting the second row with all fives. Now what is the second operation? Second operation is paint the fourth column with zeros. So we are painting the fourth column with zeros. Now the third operation, paint the third row with threes. Yeah, third row with threes. In the fourth operation, paint the third row with twos. So after the operations are done, there are 5 zeros and 3 fives and 4 twos. So answer will be 3 0 5 2 4 5 3. And one important thing is that print the color numbers in ascending order. So let's look at how we can solve this problem. So what are the observations? So first observation will be from the time complexity. So what are the constants on H and W? The constants on H and W are 2 into 10 to the power 5. Okay, so so the basic like the brute force approach to solve this problem will be order of H into W into M. So this is brute force. Brute force is order of H W into M, or you can say order of H into M plus W into M. So what we are doing, we are for each operation we are maintaining the grid, we are maintaining the H cross W grid, and when we are performing some operations, what we are doing, we are painting all the required rows or required columns with the required color. Okay, so the time complexity will be order of H into M plus W into M kind of. So now look at the constants. Constants on H and W and M both are 2 into 10 to the power 5. So this is kind of order of n square, which is not possible. So our time complexity could be order of H plus W plus M kind of. Okay, so order of H plus W plus M kind of. So we can't really maintain the entire grid. Okay, now how we can solve this problem? So let's look at our first observation, or you can say second observation. So the second observation is that the operation at the first, let's say we have done first operation on second row, and after that let's say we have done the eighth operation on the second row also. Okay, so it does not matter, the first operation does not matter, because we are modifying the first operation, which is the eighth operation. So let's say we are doing let's say a number of operations on the kth row. Okay, kth row or kth column. Okay, so only the last operation will matter. So only the last operation will matter, that is done on the current row or the current column. So for that, what we can think of is that instead of iterating over the operation, because we only need to print the answer at the end, so we are not doing online querying, we are doing offline querying. So we have to print the operation at the end. So for this kind of problem, there is a trick that as the last operation only matters, so instead of iterating over the operations from the start, we can store all the operations and iterate over the operations from the last. Okay, so how will we solve this? So we will iterate from the last operation to first operation, iterate from last. Now what will be our algorithm? So the first step will be iterating from the last. Now the second operation will come handy. So we'll maintain two sets. What one will be removed rows. that means that, let's say, or you can say visited rows, the rows which are visited, and another one will be removed columns, you can say, not CC, it will be removed columns. So let's say we have done some operation on the ith row. We'll put I, the value of I in RR, and let's say in the some previous operations we are also doing the operation on the ith row. We'll not do that operation, we will just reject that operation. Similarly, let's say we have done the operation on the jth column, we'll put that in the RC map. And again, let's say in the previous operations we have done the operation on jth column, we will not do that operation, we will neglect that operation. Okay, that's the third observation. Now what will be the more observation? Okay, now the more observation here is that let's look at the uh, let's look at here. mm, let's say initially all such zeros. Okay, now let's come from the last operation. Let's say we have made all the third row with all twos. Okay, now here you can see that when we are operating on some rows, the number of this row will not change again. Okay, I hope you get it. So we have done some operation on the last row, so this row will not change again after, because we are iterating from backwards. So we can remove this row from the matrix itself. So the total number of rows from the matrix is getting decremented by 1. Similarly, when we are doing some operation on some column, the total number of columns will decrease by 1. Okay, so that's the fourth observation. So when we are doing some operation on row, number of rows will decrease by 1. When we are doing some operation on column, the number of columns will decrease by 1. Now let's jump into the code, you will understand it better. So here I am taking H, W and M as input, and here U and P is the number of unpainted cells, because after each operation we are marking that what we are adding the total number of rows, the total number of cells that are painted in the current color. So there will be some cells which are unpainted or painted with 0. So total number of unpainted cell initially is H into W, and we are taking input as K, P comma X. K is our AI, P is our I think let me check. So K is our TI and P is our AI, and X is our XI. Okay, now we are maintaining two dictionaries, RR and RC, as I explained earlier. Now if AI0 is 1 and AI0 is 1, that means that the TI is equals to 1, and the current row is not in removed rows, so we are marking the current row as visited, or you can say RR of AI1 is 1, and we are incrementing the AI color, AI2th color or XIth color with a W number of cells, and we are marking that we are decrementing the number of unpainted cells by W. And we are also, because this is the this is an operation on the rows, we are decrementing the number of rows by 1. Okay, similarly for the column operation, if the type is 2 and it is not in the removed columns, we are marking this as removed, and we are incrementing the AI xith color by H, the number of rows currently in the matrix. Okay, and similarly we are decrementing the number of unpainted cell by H, and we are decrementing the value of W by total number of columns by 1, and at the end we are incrementing the value of the number of zeroth cell or unpainted cell by number of unpainted cell. Now a total number of colors present in the matrix will be nothing but length of d dot keys, and there will be some keys which have values equals to 0, so we are taking the list of d dot values and counting zeros. Okay, now we are iterating over all the keys, and if di is not 0, we are printing I comma di, and here we are iterating over the sorted d dot keys. Okay, this problem is quite interesting, and the total time complexity of the problem is around order of H plus W plus M, I have already mentioned. Or the first observation is important, that we have to iterate from backwards, and the second observation is that we have to maintain two sets, removed rows and removed columns, and the third operation is that when we are performing on some operation on rows, the number of rows will decrement by 1, and similarly when we are performing some operation on columns, number of columns will decrement by 1. If you have any doubt in any part of the explanation, please comment in the comment down, and if you find this video helpful, please like the video and subscribe to my channel. Thank you.